Mr. P.S. Calculus, Unit 3, Day 9, and we're going to be finding derivatives of higher order derivatives. Well, to be honest, this is kind of an easy one because it's really just finding derivatives of derivatives or of derivatives of derivatives of derivatives. It could be multiple times. That's what higher order means. All right. So first of all, we want to talk about what those notations could look like. So it says if y equals f of x, the first derivative would be y prime. You've seen all these, f prime of x, dy dx, or d dx of f of x. So that means finding the derivative of a function. That would be the exact same thing as dy dx. Now, if it's a second derivative, then it could be y double prime, f double prime of x. This means the second derivative of y with respect to x a second time. That's the way I would say that. So this is the second derivative with respect to x a second time of f of x. This is probably not going to be the most used format, but as you get higher than 2, then for 3, you would just put 3 marks, put 3's. Third derivative of y with respect to x a third time. You just find the third derivative. And then anything after 3, and I think I mentioned this in a prior video already, is that anything after 3, you don't just keep writing little prime marks. Instead, you just use a number. So like y to the 5th will be just y. This is not y to the 5th. It's y 5th derivative of y. 5th derivative of y. So very, sometimes it's a little bit hard to tell the difference between the two, but yeah, that's 5th derivative of y. Okay, so it says find the third derivative. So all we're really doing is find the derivative of this original and then keep finding the derivative over and over and over again. Of course, there are 1, 2, 3 terms. Just find the derivative using simple power rule, then find the derivative again, find the derivative again. Pretty self-explanatory, not much for me to really talk about. And obviously, if you keep finding, let's say we found the fourth derivative. Well, this will turn into 48 minus, plus cosine. If we find the fourth derivative, so f4 of x, it would be 48 plus cosine of x, because, I'm sorry, plus sine of x, come on. Derivative of cosine is negative sine, and opposite of negative sine would be positive sine. So that's positive sine of x. And then if we found the fifth derivative of x, it would be just cosine of x. Now, the reason why I took it a few steps further and I wanted to find a couple more is because I wanted you to realize that if you do sine and cosine or any trig function, obviously it's going to go rotation. It's like a base 4 basically. It's going to be rotating to the exact same thing every 4 times you do the derivative. But if you're doing it just of a polynomial or just a constant, sooner or later, if you find the derivative of something, it's just going to end up being a straight line. So it's always going to end up being a constant with no slope in the end. So if you differentiate anything else other than like a trig function where it just keeps repeating, or e to the x, exponentials, things like that, it's going to end up just being 0 in the long run. It just takes a matter of, how many times am I going to have to differentiate to make it that. Find the second derivative. Well, constant multiple rule. Secant of x is tangent times secant of x plus e to the x is itself. The first one was pretty easy. This is product rule, so you got to be careful there. So see how I used product rule, and then I cleaned it up a little bit to get the answer. All right, second derivative of this one. So first thing I do is change this to this because I don't want to have to use quotient rule when I do the chain of this. It'd be a lot easier if I don't do that. Of course, like I say many times before, no matter how you do it, you're going to get the same answer. It's just knowing the easiest and best solution is going to be very vital to save time on the AP exam. Now, first thing I'm going to do is differentiate this. Of course, there is chain rule involved here. So constant multiple rule times derivative of sine is cosine. So cosine of itself times the chain. The derivative of the inner function is 1/2. And then that cleans up nicely to this. Half times 8 is 4. Okay? And then we're finding the derivative of this again to find the second derivative. So it looks like constant multiple rule again. Derivative of cosine is negative sine of that argument times, once again, the chain of the inner functions. And then just clean it up a little bit. Pretty self-explanatory there. All right, a couple more examples. Given y squared equal this, find the second derivative. Find the second derivative of y with respect to x the second time. Well, they only gave us the original function, so we have to differentiate it twice. First differentiation, fairly easy. So 7 dy dx plus 4 is here, right? Oh, I didn't see this over here. Sorry, it's an equation. So it's 2y times dy dx, and then get the y's together. So we got some implicit differentiation. That's always good to review. So we found dy dx is this, okay? So I've finished. I found dy dx is right here. But remember, we want to finish it. We want to differentiate it a second time. And I could... Actually, this is not so bad. I could use quotient rule on this to do it the second time, but it looks like I chose not to do that. So I chose to move this up to the top and then just use chain rule. It does not matter. As I've already stated in this video, it doesn't matter which way you do it, you're going to get the same answer. And of course, if you look at the final answer, look right here. This is to the negative second, which means that's going to go on the bottom. So you kind of recognize where quotient rule ended up in the answer, because that would have been your bottom, and that's the bottom squared. Now, it does end up actually, it looks like it ends up being 2y minus 7 to the third power, because once you multiply this by this, it becomes a third power. But I digress. Okay, like I said, you can do it either way. It does not matter. But when you do this, you're just going to use chain rule. Negative 1 times 4, then multiply it by the chain. You got to multiply by the derivative of the inside, and that's right here. And then, depending if it's a multiple choice, if this is a free response, you're free to leave it just like this. If this is a multiple choice, I can pretty much guarantee you the answer is not going to look like this. They're probably going to make you clean it up a little bit, but you never know what you're going to get. All right. Couple more examples. I think I have 2 more. So, it's good for us to remember how to do those F inverses, how to find derivatives of inverses. Well, that's going to turn into this. That's 1 over 1 plus the argument squared times the chain, the derivative of the inside. Well, that turns into this. And then we want to do it again. So we're going to find the derivative of this again. And it looks like I chose this time, although I didn't have to, I chose to do quotient rule this time. I could have taken this denominator, moved it up, and made it to the negative first power, and then just use chain rule. Either way, you're going to get the exact same answer. But in this case, it looks like, quotient rule, after you get enough practice with it, you kind of recognize that it's not going to be that bad. So low d high minus high d low over the bottom squared. All right, last one. What is the value at the point of 4, 3? Okay, so they're telling you if x squared plus y squared equals 25. What is the value at the points? What is the value at that point of 4, 3? All right. You might tell that I just had an edit there because I was trying to figure out what the question was, and the way I read it, I missed this. I totally missed this. I was like, wait a second, there's no question here. What's going on here? All right, it says, what is the value of the second derivative at the point 4, 3? Okay, that makes a whole lot more sense. So we have to differentiate this twice. We start with the original, differentiate it right here in red, solve it down to dy dx is this. And then we have to differentiate that derivative again, and it's easier just to use quotient rule, as you can see. Don't forget to replace dy dx, the derivative of y, replace it with this. And then you could simplify this down probably, but I'm going to be honest, it's not worth my effort because time is everything on the AP exam. Don't simplify this down. Just start plugging in 4 and 3. Plug in 4 and 3 and simplify, and boom, there should have been your answer of A. There is no reason to simplify this down. I know it's going to take more work simplifying this than it is to just actually evaluate it in the state that it's in. If all you're being done is asked to evaluate some sort of second derivative or first derivative, don't feel it necessary to simplify this to the most simplified version of that expression. There's no need for that. All right, thanks again for watching, and I will see you on the next video. I think this wraps up Unit 3, so I'll see you again in Unit 4.